And from G3 PLC Alliance, we are very pleased to join this session today. As mentioned in the webinar invitation, power communication is a very powerful communication technology for the smart grid. It uses the existing power lines for communication, and like Ravindra already mentioned, there's several key advantages. The cost of installation is lower as there is no need to install any wires. Cost of meters is lower due to the lower bill of materials. And the cost of communication is lower as there are no telecommunication fees to be paid. And another main advantage is that utilities use their own network for communication, so they are not dependent on commercial telecom operators, which have their own development cycles with their own timelines. Now, PLC is the mostly the widely used communication technology for smart metering in Europe, but not just in Europe. G3 PLC is a proven technology with more than 50 million devices in operation in over 30 countries. There are many implementations in Europe, in Asia, in Africa, South America, and the successful smart grid pilot in Tripura with 40,000 PLC meters, which was a topic of a previous webinar, shows that PLC also is a suitable communication technology for the smart grid in India. Now, G3 PLC is supported by an international group of almost 100 DSOs and industrial players, and they all invest in the success of G3 PLC now and in the future, and that is the G3 PLC Alliance. And we as G3 PLC Alliance will be very happy to support projects and utilities to work successfully with G3 PLC in India, together with our members like ST Micro and Enedis. And we will make a presentation during this webinar. With PowerCom, who was involved in the Tripura project, and with many other of our members active in India. So thank you again, Ravindra, for inviting us, and I look forward to the presentations and the discussion. Thank you.
Yeah, thank you. Yeah, so IEEE Standards Association under the Industry Connections activity, which we call IC, Industry Connection Activity, has initiated a program towards setting up of multiple power line communication test beds in India, engaging various stakeholders from utility, industry, and academia. I have the pleasure to welcome the chair of IEEE SA Industry Connection Activities in India for establishment of PLC test bed in India, Dr. Pavendra. Dr. Pavendra is the Director R&D at ERNET India under Ministry of
Electronics and IT, yeah.
Electronics and IT, yeah.
Yeah.
Okay.
Thank you, Ravindra. Thanks very much. And as a chair of the IEEE PLC Testbed Working Group, I would like to express my sincere thanks to ISGF Chair Reggie Pillai, and also IEEE colleagues Ravindra and Reena in this wonderful webinar where we would like to hear from the experts in the PLC worldwide. I'll just brief a couple of minutes in terms of what is the deliverables in terms of the PLC working group activities. So one is the outreach programs, the one that we are having it right now, similar to the webinar that we are having now. So we would like to conduct events which are PLC focused, how PLC as a technology can be leveraged in India. So those initiatives we are undertaking. And also the major focus of the working group is on establishing 2 to 3 test beds in India, focusing on different use cases. So one of the test bed that we are currently working on at IIT Madras Research Park is in a smart building power line communication test bed with support from SLS and ST Microelectronics in energy monitoring, indoor air quality and various parameters in a building environment is being monitored with powerline. That is one use case that we are currently working on. And other use case that we are trying to initiate is with Tripura State Utility along with NIT Trichy in customer metering data analysis in the AMI environment. So that is also under discussion, and DESCOM CPRI is also we are pursuing to initiate other activities. And there is an automotive use case which IISc is working on. We would like to see how PLC can be leveraged in automotive use case. So additional test bed opportunities are also we are trying to see in the next 1 year time frame. So in terms of the this webinar is quite relevant in the context of initiating new activities under the working group jointly with various stakeholder, including utility, G3 PLC Alliance, and many other and industry. We would like to initiate more activities of this kind. And if there is any interest among the participants in Powerline communication, we would like to hear from you. You could reach to Ravindra or myself in taking this forward to see how you could contribute to the working group activities, and also we could provide the connect with the utilities and the industries. So thanks everyone for joining, and we look forward to hearing from you further. Thank you.
Yeah, thank you, Dr. Pavinder. So I have the pleasure now to welcome in, of course, there are partner Reji Kumar Pillai, who is the President, India Smart Grid Forum since its inception from 2011. And we are proud that he is the chairman of Global Smart Federation since November 2016. All of you know he is an international renowned expert with nearly 4 decades of experience in electric sector. He is spearheading for a mission to leverage technology to transform the electric grid in India and provide 24/7 reliable electric supply to every citizen at affordable cost. So I request Reji for context setting. Over to you, Reji. Hello.
Yeah. Good morning, good afternoon, good evening, all participants and my co-panelist. It's a pleasure and privilege to moderate this session and being part of this August forum. Today is, as many of you know, is World Energy Storage Day. There are many parallel events happening, and I had committed to join something at 7 o'clock. So we started on time, so we had to try to finish by 7. So I wouldn't get into too much of details. As we had another session in July on PLC, which was primarily to showcase the largest PLC implementation in India for smart metering in Tripura, where 40,000 meters are working for the last 2 years. And last year in 2019, ISGF, our innovation award, we had awarded the first prize to the smart grid pilot project in Tripura. So we have the pleasure of having the managing director of Tripura distribution company, Dr. M.S. Kele. He is also here in the Q&A session. He will be answering questions. So as I have been maintaining, ISGF has been advocating that we need to look at all technologies. Communication technology should be kept neutral between the meter and the control center. Any new technology or whatever is a reliable and affordable technology, we should keep it open. India is a very large country. We have more than 250 million customers, smart metering, and whatever is the most appropriate in a given geography, we should go for that. About 15-20 years ago, there have been some trials of PLC in India in different academic institutions and couple of utilities. Those were very old generations of technology, PLC technology, including there were no standards. They also broadband on power line. These were all tried out in different places with a mixed success. So by and large, by 2007, 2008, even before 2010, many of the DISCOMs have written off PLC as a technology which may not be appropriate for the distribution system in India, where we have aluminum wire joints which are not twisted joint, where there are higher losses or attenuation, and this is not going to, and our network keep increasing. We add more and more number of new customers every month, every year. So every time more customers are added, we have a challenge in tuning the entire PLC network. So this kind of complaint we used to hear. But over the years, I have seen closely large implementations in Europe. You will hear from that one of these presentations today that 27 million meters already installed in France using G3 PLC technology. Another standards association, PLC association, is Meters and More. They have done more than 30 million meters in Italy, and still there is another Prime Alliance. So they have done in Spain and a couple of other places. So altogether, as Leon has mentioned, there are more than 100 million PLC meters deployed across the world, including Latin America, and we are very happy with the result of the Tribra project, and we've been talking to our distribution companies that time has come. We should do more trial on PLC in Delhi, in Bombay, in Bangalore, and other places. As in the last webinar, I promised you, Dr. Pavindan, that we will definitely take up this PLC pilot project in one of the metro cities with the DISCOM very soon. Let this lockdown and other COVID-related slowdown, let it be over. By end of the year or early next year, we will start a big project. We will look forward to support from G3 PLC and other PLC associations for participating in that. So key advantage of PLC is that, as Leon has already mentioned, we are using the same power line. Anything happening on the power line, immediately from we get to know. And besides, if you do PLC for smart metering or on a distribution network, you can use the same communication technology for distribution automation, transformer monitoring, several other network automation related solutions. Everything can sit. It's a technology which is owned by the DISCO, and you are not at the mercy of a telecom operator or somebody else, a third party provider of a. So this is something which is very good for the overall smart grid implementation. And we are seeing a scenario rooftop solar in a building. We just, Dr. Pavindan mentioned about the smart buildings. A rooftop solar in a building and a electric vehicle charging infrastructure in the same premises. The EV, the rooftop solar, the smart building, all of them interacting with the distribution network. And if there is PLC network, communication network, you don't need to look beyond for other communication technologies. All these different pieces which are becoming significant pieces of the electricity distribution network, which were not there 10 years ago. Solar were very minimal, electric vehicles were nowhere on the sphere. These are all becoming a significant component of the evolving 21st century. All can be communicated and controlled using PLC net. The building management system, where the area of current work is mostly from a grid interactive building, which could buy and sell electricity from the power market. India today has a real-time power market. When the cost of the power is less, we buy from the grid. When the cost is high, we can sell it back to the grid. You can generate and you can store. You can also aggregate the electric vehicles as virtual power plants which are connected to it. So grid interactive buildings which will be connected, the BMS of the building connected to the distribution management system of the utility is a architecture which we are advocating and promoting, and we are trying to make it the pilot projects based on that. So all these are going to be, you will hear more and more in the coming days. So there are some very excellent technology presentations. First, I will invite Mr. Manoj Kumar to make a presentation on the evolving PLC technologies for the electricity distribution network applications. Over to you, Mr. Manoj Kumar, and please put up his slide. Mr. Ravindra introducing Mr. Manoj Kumar.
Thank you, Reggie. And
okay, we'll straight go to the presentation. Okay, everybody knows you. Go ahead, sir.
I am just wondering if my slides are visible already.
Yes, we can see it. You can go on the presentation mode, from the slide mode to presentation mode, then it will be bigger. Just go to the presentation mode.
All right. Okay, is it good?
Yeah, this is good, very good. Good luck.
All right, so 5:50, I should take 20 minutes. I will try to be my best in those 20 minutes. So good afternoon, everyone. Good evening. I suppose no good morning. I'm Manoj Kumar, working in ST Microelectronics. It was a little bit introduced already by Dr. Pavindan and also Ravindra. So first of all, it is a pleasure and honor, and I am really humbled, truly humbled, to be presenting to this august audience. This is outline of my presentation. I would speak a little bit about PLC in general, then smart grid and in particular. More importantly, I would be focusing on the use cases as they have happened across the world. And then I would talk about hybrid PLC or PLC plus RF, and more importantly, in relation to G3 PLC hybrid, which essentially is PLC G3 plus RF. I would be speaking more and more about it. One slide about my company. So ST Microelectronics, apart from revenue and number of employees, we are proud in saying on single introductory slide that we are signatory of United Nations Global Compact and also member of Responsible Business Alliance. That is about the corporate sustainability, and these are the two really values that we are very, very proud of possessing. In terms of power line communication, as Mr. Reggie mentioned, there are several standards and alliances. Some of them, or most important of them, are listed here, starting with the G3, Prime, meters and more, IEEE. So my focus today, I would be focusing more and more on G3 PLC part today. About ST, we have more than 130 million smart meters with ST inside, and this goes on to say that there is G3 but there are others also. So this is combined or cumulative experience of ST in terms of smart meters using various standards. Very quick reminder, I know that many of you are deciding which bands we should be operating, etc. But just to say that in the remaining slides, I would be mentioning FCC. FCC is like 10 to 490 kilohertz band. I would be mentioning about channel A band. A band is something that we can imagine is the one that is for metering, but also C band, and C band is something that is used for home networking. Just a quick recap of some of the frequency bands that I will refer later. Key features of G3 PLC. It was mentioned very well by Leo himself. It's very, very robust. Goes up to long distances in the medium voltage also, and in the FCC band. So FCC band would mean that you have the higher data rates as well. There is a security in terms of what is the information, its confidentiality, and the person who is authorized to access only accesses. That is what is meant by security here. And then it is end-to-end IP communication based on IPv6. So all the advantages that IPv6 offers are there already as part of this. And of course, it is an international standard. That means it's based on open standards. And later on, when we will talk about RF, the good point is that when you add hybrid G3 PLC, it is backward compatible with standalone G3 PLC. And that is another way to say that whatever is done with G3 PLC today, that remains valid when you add RF to it. That is what we will discuss later. As said before, more than 50 million installations of G3 PLC exist today. That goes on to speak about reliability of G3 PLC itself. Okay. One very quick comment about a specific device that we have. I would not speak about its details, but just to say that when we talk of PLC, PLC has been mainly used in reference to metering today. And when we talk of metering, you have certain kind of PHY, MAC, then some, let's say, communication interfaces or IPv6 kind of stuff like 6LoWPAN. And then on the application layer, you have DLMS and COSEP. So we have one device which is called ST8500, which is kind of programmable. Programmable means if you want to program G3 PLC, you have it. If you want to program something else, that can be customized. Hence, the blue portion over here, let me change my pointer to laser pointer. So the blue portion over here, which corresponds to this. So this is kind of programmable portion and is a turnkey stack available from ST, and rest of it is something that customer can build its own application like DLMS and CUSA. So each of the meter that we would be referring in the following slides consists of certain parts. Of course, it starts with the mains. There are some line drivers, a modem itself, then microcontroller, display if it is for in-home display, and then of course certain backups if we must retain data when power is not there and so on. Modular architecture is really the key point about what we offer in this device ST8500 with the minimal BOM, and of course it is certified, and there are multiple millions of devices that are operating in the field under various standards. To talk about some of the use cases, clearly most successful use case in PLC so far has been metering. And in metering, one of our experience has been in Italy, where with a partner like Enel or eDistribuzione, we had first rollout of 35 million meters, and it is going for the second rollout. And it is interesting to understand that first rollout was done really 15 to 20 years ago. And then as the network evolved, there were more and more requirements. It was felt that there could be some additional channel that could be useful, that could be introduced in a effort to provide some backup channel, or maybe to introduce some additional metering, like if you want to have metering or water meter or other meters also through the RF channel. So this is also interesting that what is recommended is that when we talk to the concentrator, we talk on one band, and when we talk in the home area network, we are on the other band. This is to really minimize the crosstalk. And in terms of what was done in this particular pilot, so PLC band 1 is Senelec A and Senelec C is on the other side, which is the way that Senelec bands were also spelled out. Another success story is about smart city. So in smart city, of course, everything is service driven. That means you would like to say that if you would like to kind of know what is the condition in certain area, so you get inputs as sensors, and then maybe the output could be that if certain conditions are meeting for a particular output, particular actuation, you actuate that. So with that, what you need is really some kind of concentrator. So here you can see where my pointer is pointing out. There are multiple intelligent peripheral nodes. Each of the node could be a sensor, could be an actuator also. So imagine a scenario that maybe if there is a water logging in certain area, then certain pump should be switched on. If this be the case, you are able to get this data on to the PLC, send it to the mobile network, and entire this decision making is happening over here. So all those local and the field functions in terms of data collection, but also actuation, can be done and have been done. And whenever you see this kind of name like Highmark, or you saw Enel or eDistribuzione on the previous slide, that means these are the people who have actually done it. It's not just a possibility, it's not a lab prototype. These are the real field conditions. Another point very important about PLC is that you can use it for actuation. For example, you can actuate certain camera. So camera may communicate as it should communicate on different channels, but actuation of the camera based on certain conditions happens through PLC. Moving on. This is a installation that is done in industrial environment, where more than let's say 128 nodes have been installed in the industrial environment. Then you see one of the pole which is simple light only, but the other one is which is having sensors, actuators, everything onto this. And there has been two things which are noteworthy over here, that the PLC communication success rate is close to 99%, but the request or the response time is as less as 250 milliseconds on a PLC. And this is a fully functional, fully working field pilot operational in a warehouse in Italy. This is interesting that PLC has multiple usages. I took this particular one because I found it more interesting than others. So here what you see on the top left is, sorry, I have to stay here a couple of times because there is a timer. So this is a railway track which is going through the snow. So what happens when you have to change the track? And if there is a lot of snow, the actuation may not happen. So what is the remedy? Remedy is that you should be able to start the heaters in certain manner after detecting that there is a lot of snow, so that when actuation is needed, you are able to change the track. And here exactly PLC is used in this condition. That means you go on monitoring the temperature and you know when the heaters have to be actuated, so that when it is required to move the line or to switch the line, because the train has to follow a certain track, it is switched on time. And this is the safety critical application, as you can see. Likewise, of course, there are applications in the tunnels that I have skipped. I will skip the tunnel application. It is more or less about how we kind of see if everything related to emergency or lighting is functioning well or not. Let's look at PLC connectivity in smart solar. So smart solar, particularly in Americas, that presents a very interesting scenario. So first of all, there is a PLC over DC line that goes to PV array, and AC line that is the usual one. The requirement today, as per NEC, which is like National Electric Code of USA, requirement is that you should be able to kind of isolate a certain module if it is malfunctioning. And this job is done by PLC, because each of the junction box is connected to the PLC, and PLC takes care of isolating any faulty module as per the standard requirements in North America. Another one, it is just to say that it looks like very obvious, but why I kept it here is to give the idea that PLC is actually invading into typical IoT applications, in-home display, or if you should have a home energy management system, smart home lights, etc. Typically, we talk in terms of lighting systems or in terms of IoT systems these days, but all of these are the capabilities of PLC as well, without any additional investment, as has been mentioned by Mr. Reggie, Leo, and everyone before. And very interesting use case is emerging where RS-485, which is happening, which is there in the data centers or base stations, and you are in any case having power, so why use any additional RS-485 as well? So you can survive with the power line that is already there. This is the one which I find more emerging and more interesting. So first of all, why it is being used. So what you see in the green is the connection between EV, that is electric vehicle, but also electric vehicle supply equipment, or call it charger. Okay. So between these two, there is a power line communication of certain type, and between this charger and the grid, there is power line communication of another type, and I will speak about it. For example, let's say we have G3 PLC between the grid and the station. But when a vehicle is charged, there are a number of parameters that have to be monitored, like battery, state of charge, and also seeing that grid is able to supply what is demanded, or the demand scheduling and everything. All of these functions are done by G3 PLC on the network side, but locally there is another power line communication which is like broadband PLC. You can say home plug, green phi, and so on. So there is a requirement of larger data rate on this side than even the other side, which is interesting. And this charging system is called CCS, or common charging system, which is using this PLC. So it is important. And of course, on the right side, I am mentioning that, of course, we have corresponding devices as well for this side also. And it is one of the very, very interesting applications of PLC. Many times we don't even realize that there is a PLC on this side, because it is part of the connector in certain connector category. Then comes our new hybrid PLC technology, so 603. So in this case, imagine that if each of, so first of all, in the diagram, solid line is representing PLC communication and dotted is representing RF. So potentially you could have a node which is having the capability of PLC and RF at all the time. What is the advantage? That it can provide you an alternate channel. But also imagine that from this node to the other one, maybe PLC link is better than RF, go to PLC. But between these two, perhaps RF is better, choose RF. And then you don't have to do it manually. It is done by itself automatically. Of course, there are applications where you can have your own logic, but when it comes to particularly and I will skip this slide just to say that this is one use case where you have a gateway RF, and then certain data is coming from RF only. The other is on PLC also. So it's a case of hybrid RF plus PLC. Let's talk about G3 PLC hybrid in general and why. Because you could have your own RF implementation as you want. You can have your 6-LoWPAN, or you can have your star network if there are a few nodes and so on. What is interesting about G3 PLC hybrid is that I mentioned before that it is backward compatible with G3 PLC only, but we have the possibility that you can have this RF which is fully supported by the standard. And it is important for us to understand that the large scale deployments happen when it is supported by the standard, but also perhaps certified. And I understand that soon there should be certification program for the G3 PLC hybrid, as it is already for G3 PLC. So here you can have the clusters which are independently connected only through PLC, the solid line, and then through RF in between. And the idea is that it can be kind of jumping over the transformers also if you look from the real field conditions. So there can be mixed situation, there can be independent situations, and all of them can be connected through RF or through PLC. Good point is that one doesn't need to know if I am RF or if I am PLC. I move on. Some installations which have already happened. This is a slide that is coming from ADT Group of Russia, and they had an interesting situation that there was some PLC installed in some harsh environment. There were certain KPI that they were getting, and they wanted to kind of increase this KPI. They introduced this PLC plus RF hybrid, and this system is operational since March of this year, and they are reporting really finally, they are reporting almost 100% of data collection from all the meters managed by the data concentrator. And here you can see the configuration is pretty much following what was described in the G3 PLC hybrid on the previous slide. These are some results on the right side. I am skipping this. Now I come back to India, and before I speak about what we can do in India, I felt I should also share with you what we are doing in ST Microelectronics. So we have a interesting innovation studio here that we call as Da Vinci Innovation Studio, which is like 50 by 20 meters, 1000 square meter in-house. And here we have installed several kind of technologies, all types of PLC. When I say all type of PLC, of course, there is G3 PLC, but also others. And then there is sub-gigahertz, there is 6-LoWPAN, and Bluetooth to speak a few. Here, what is done is that we are able to demonstrate everything. For example, if you have to control your home appliances, be it fan, be it washing machine, or the mixed load, everything we are able to demonstrate. But we are able to demonstrate on the threadbare boards, open code, everything written by us in that sense. We are able to demonstrate, and this is to say about the enthusiasts. We have built a DC fast charger already, and what I discussed about CCS is something that is underway. Hopefully, in 6 months' time, we should have something. And when I'm saying this, it is not to say that there are no such systems in the market. Yes, there are, but I'm talking of the development that is being done in-house here. Another slide, at least 2 years ago, we made our own pilot using G3 PLC. On this, if you look at the cursor, it is boundary of ST Microelectronics at Greater Noida. Expanded view of one of the nodes is like this. So there are two street lights which are being controlled by one PLC node. And of course, street light is also designed by us in terms of driver. So it was possible to kind of integrate with the PLC G3 very, very easily. Here you see there is some kind of very simple wiring connect. We have the possibility that on any such wiring connect, we can attach one in-home display equivalent stuff, and we can really monitor entire stuff that is happening in terms of when the nodes are joining or not joining, if there is a problem. So you can have on, off, switching and everything. And this pilot is working for last 2 years and on UP State Electricity Board power supply, because it is external. Good point, everything is designed in a lab. This is the hybrid version, but this is not strictly G3 PLC. G3 PLC is on the left side, but RF we implemented by ourselves. That was at least 2 years ago, just to share with you that there are a number of developments that are happening over here. I jump to now the real proposal that we could have. So I talked about ADD group earlier, and they did something in Russia. Like ADD, there is another company, or there are many companies. One of them is Sejemcom, which is very actively working on G3 PLC hybrid. And when I say G3 PLC hybrid, I want to reiterate one more thing. One is to have PLC plus RF. Another is to have PLC plus RF, which is following the standards. And when I'm saying G3 PLC hybrid, I'm referring to that. So there is a development that has been done by Sejemcom, and this kind of system is available. You know that when you have any kind of network, it has its own limitations as to what could be the best performance that you can get, and mixing another kind of network with the possibility that you can jump to either one or the other depending on which is giving you a better performance, it improves. And there are now use cases already, and this is done by Sejemcom also. I jump on to the next one just to introduce this company. So they are number one in distribution for gas and electricity in Europe, Middle East, and Africa, with 65 million smart meters installed, 30 projects completed, and 10 million meter manufacturing capacity per year. Why I'm giving this information to you is that in collaboration with the Sejemcom, we as ST Microelectronics are in a position to say that if there is a interesting DSO, capable DSO for its part, we could discuss a possibility of a hybrid pilot installation, which would be based on hybrid PLC, as has been said before. The picture over here is depicting G3 PLC plus RF. So we are available to discuss it any further. And here you can see there is a contact from Sejemcom also. You can note this name, you can contact him. Of course, you can contact ST also. We are more than available to discuss it further. Summarizing, so PLC is really the most suitable technology for smart grid connectivity. It is reliable, field proven. PLC continues to evolve. One more thing I wanted to say is that PLC continues to evolve, but it is not evolving at the same rate as some other technologies could be evolving. Let's say telecom. So when you have PLC and communication is happening on PLC or your own RF versus the communication is happening on a technology which is from a different field, like telecom, call it 2G, 3G, 4G, 5G, or 6G, they are evolving much, much faster. And this field remains a field where you do an investment, but then you would look at a period of 15 to 20 years or perhaps even 25. So one needs to see which technologies would continue to be around for 20 years because your focus remains energy, not necessarily the telecom. So this is one aspect that I just wanted to say. And PLC and hybrid PLC are really mature, and these are suitable for large scale deployments, including India, because wherever one kind of network is working, we have it. Of course, backbone remains PLC, but wherever there is a need, there is RF, and such a pilot project we can do in India. And with that, I really come to end of my presentation. Thank you.
Thank you very much, Mr. Manoj Kumar. That was wonderful. Those who have, the participants, those who have questions, you may please post it in the chat box. We will answer that. Some of them I have already typed and answered it. Some of them we will give it to the panelists to answer during the Q&A session. So I had not introduced, the slide was not there. So Dr. Kumar is working with ST Microelectronics for the last 21 years. So there's a, you can see been working on all new emerging technologies like BLE, sub-gigahertz, power PLC, metering, motor control, many areas. So is also leading the ST partner program in India with a mission to provide global visibility to Indian partner companies. Thank you, Manoj Kumar, and apologies that we couldn't introduce you before the talk. It was good. So now we have Cedric coming in, and Cedric, you can switch on the camera now. And Cedric is the program manager. EDF is currently doing the large smart metering program, which is 35 million smart meters, of which they have already completed 27 million installation. Despite COVID, every day they are still installing some 30,000 meters. He will be talking about all that in his presentation. Over to you. The program is called the Linky program of Enedis. Those who don't know about Enedis is the distribution company which is carved out from the old EDF. EDF has been made into three. Original EDF is generation and R&D. RTE is the transmission company in France, and Enedis is the distribution network operator in France. So with a customer base of 35-36 million customers. So over to you, Cedric.
Thank you. Do you hear me well?
Yes, very well. Very well.
Okay, great.
Go ahead.
Okay,
go ahead.
so hi everyone, and thank you for the invitation. It's very good for Enedis to display what we are doing in France and to share with us what we are doing in France around PLC and smart metering. So if you can go to the next slide. This is the picture of the Linky projects. So Linky is a national rollout of a smart metering program. So it's quite a big one, at least for the Europe. It's 35 millions of meters and 600,000 of data concentrators. So we will deploy them from 2015 and 2021. So over 6 years, we will deploy these 35 millions of meters, which is quite huge. This is a quite high cost program. So we have a 5 billion expense for this to deploy all the meters, and we will need a lot of people to deploy them. So we hired roughly 10,000 people to do all the installation of the meters. We around 10,000 people. We have half of them which are on the field to deploy, and we also have some people to work on the devices, on the specification, all the tests, and all the information system to build. We choose Enedis to have multiple suppliers, so we don't rely on a single solution. We have 6 different vendors, which you may know. They are Sagemcom, Alphanar, Landis+Gyr, Cahors, Itron, and Honeywell. So we are using these 6 vendors that build a data constructor of meters, and we have different type of meters. We have 1-phase or 3-phased meter. Some of them are connected from the bottom, some other from the top. So we have different type of meters, and at the end they will all work together. So this is also something very important for G3 PLC, is that it is an international standard. So you can mix different type of devices together, and they work perfectly well. And it is the same type of standard as on the internet. You can have multiple devices all over the world communicating together. This is the same type of technology in France. We mixed all the different suppliers, and they work perfectly well anywhere in France and whatever the vendor is. Next slide, please. On the next slide, I put some big numbers just for you to have a big picture of the deployments. So they are up to date. So it is the number from September 2020. So from now, we now have in France more than 27 millions of G3 PLC meters on the field. The rate, the speed of the rollout is that we install more than 30,000 meters a day, which is quite huge. This means, for example, that by the end of this talk, which is a 20-minute talk, you will have another 1,000 Linky more to be deployed in France. So it's quite fast. Also, the production rate is quite high because our partners produce 750,000 meters per month, which is huge, and there's a lot of logistic to deal with. And the good news also is that you have to keep in mind that 100% of these meters are using PLC. There's no GPRS or other kind of wireless technology. They are all using PLC. So this is a choice that we made in Enedis. 100% of our smart metering, so 35 millions by the end of 2021, will use only PLC, and it will work anywhere in France, whatever the devices, when it is Itron or Landis or Sagemcom, whatever, then we all work together using only PLC. And G3 for the most of the part, 95% will use G3 PLC. The first one that we installed in 2050, we're using G1, which is an SFSK technology. It's another technology, and we now move to G3 PLC only. The performance are good. We have more than 99% of success rate on the remote operation, and the daily collection rate is above 98%, which is the target we have from the regulation we have in France that is controlling the good operation of the system. Next slide, please. On the next slide, this is also for you to have the big picture of the communication chain. So I will talk about the link emitter, so the smart meters and the data concentrators. They are using PLC only, but you have to keep in mind that you have also some other parts of the system which is in the information system. This is something I won't talk about, but it's something you should have to keep in mind, is that it's not only puts smart meters and data concentrator on the field. The smart metering program is also all about the information system or the supervision system, all that you need to maintain these big networks. And so the Alliance will also in the next weeks have a webinar on that. It's what do you need in addition to all the meters to make it run perfectly fine. The three key points to remember about PLC that it is bidirectional, so you can send and receive information. It is not just a push of data. You can have a bidirectional exchange. It is also interoperable, as I said, so you can switch between any kind of suppliers that work together, and it is scalable. So, for example, in France, we can have very small networks with only 1 meter beyond a single DC data concentrator, but you have also in some urban area, you can have up to 1,500 meters beyond a single data concentrator. As it is exactly the same meter and the same data concentrator, you didn't specify a data concentrator for urban or rural area. They are all the same. All the meters are the same. Where whatever the region and the type of topology you have, it cope with any kind of topology. And also because you have this bidirectional link and it is secured, you can also upgrade the firmwares, because it is important to know that these meters are on the field for 20 years, which is very long. So they have to be in line with all the application that will come up in the next years, like electrical vehicle charging, PV inverters, all these new usage will have to these smart meters will help to this new usage. So it has to evolve and to have some updates according to this. On the next slide, I done a quick focus on the use cases. So the three main targets of the service is for sure to ensure the metering application. It's basics. In France, we just collect the index once a day. So every 24 hours, we have the index, and you can have, it's an option for the customer, the 30 minutes load curve. So you can have your load curve. So it's 48 points per day when you can check your production, if you're producing some energy with PV, photovoltaic panels, for example, or just your consumption. And so you can have it, but it once a day, not on real time. It's not every 30 minutes. It's once a day with all the data of your day. Also, we use this system to monitor the grid. So I will present, for example, 3 services about outage detection, grid balance, and power quality. And also,
sorry to interrupt. We can't see the slides, Mr. Ravindran. We can see other document that you maybe you're working on. Yeah. Thank you so much.
Thank you. And also we can use, because of a bidirectional link, we can enable action on the grid. So we plan in use these smart meters not only to read some power consumption, but also could control the grid in a way. As I said before, those PLC can cope with any kind of scale, from 1 to 1050 and 500 meters, and it cope with any kind of topology. So, for example, we often have the question of what is the range of the PLC and so on. Actually, I don't really care about the range. What I can say is that basically we put meters anywhere in France and it's working well. So it seems to cope with any kind of length of wires, impedance, noise, and so on. This seems to work well. And this is also due to the protocol which adapt to these noises. It has multiple frequencies. It has a tone map exchanging and so on. So it copes with any kind of topology and noise and length and so on. It seems to work in any topology. At least this is what we saw in France. And so I'm quite confident that in India, it may also work well because in France, we have a large diversity of type of grids. So I'm quite confident that it should work well in India. On the next slide, I'm talking about the grid services we build upon G3. So this is services that won't be possible to make without G3 PLC because it's based on the information taken from the G3 PLC. So on the next slide, I'm presenting these three services. So the first one is the power outage detection. The second one would be phase detection, and the third one would be the grid cartography consolidation. So to have a view of the grid and the map of the grid. And so all of these services, they are pure software based. So this means that you don't need any additional devices than meter and data concentrator using G3 PLC. It is just software. You don't need additional devices in the substation or in the low voltage grid to do this. The big, I think, advantage of G3 PLC and PLC in general is that it is by nature connected to the grid. So this means that every time you communicate using PLC, you have information for the grid because you use the grid, you use the wires. So each time you communicate using wires, you know that the wires is on, you know that the electricity is there. And so this is in a way the beauty of the PLC, that every time you communicate, you use the grid and you get some data about it. On the next slide, I'm describing the outage detection services that we develop in Enedis. And this is also a specificity of G3 PLC, which is quite good to know, is that in G3, you know about the neighborhood. So you know who is around you, which is not always the case with other technology. So for example, on these small networks, by just looking at the neighborhood of 3 nodes, so the data concentrator and two meters, you can have a complete vision of the grid. Just using the neighborhood information, you know what is going on around you. So if I go to the next slide, this is some representation of the neighbor tables. This is information that is available using the G3 PLC protocols. You have what we call neighbor valid time. So this is a freshness of the neighborhood. So it's like the last time you get an information from your neighborhood, it refreshes this timer. And so when everything is going fine, the freshness is to the maximum limit, which is 255. So this is a case where everything is okay. Everybody is communicating together. So everything is fresh, everything is okay. If you go to the next slide, you will see that's something that can happen is that when you have an outage, you may have one of the meters that is no more communicating because of the outage. And so you will see in the neighbor table that the freshness of the data is not there. So you will have this decrease of the value, and you can detect that something is going wrong because you don't have any update from these neighbors. And this is how actually we detect the outage. So if you go to the next slide, you will see some results that something that the service that in less than 3 minutes by you. I have to go back to the slide before, please. It was a graph I was presenting. Yeah. If you could, please, yeah, go back to the slide number 11. Yeah, and so what we saw is that in less than 3 minutes, we were able to detect the outage of 40 meters, which is a big outage, and we were able to detect it quite fast. I don't know if you hear me still, but yeah. Okay, so
Yeah,
I'm on.
I-
Okay, I'm on slide 12, right? So the next services is a phase detection, and it is something that is quite useful for DSO like Enedis, and I guess all of the people that are working with DSO know that. That is very important to know on what phase your matter is connected. For example, in the Linky program, it is just a need and part of the business plan. We have to have these services to monitor the grid. So if you're going to the next slide, I'm explaining how the PLC is, and G3 in particular, is computing it. So as PLC, we know when we send the frames where in the information at where in the period of the frequency of the networks we are. And so every node has its own reference based on that. And so when you get a frame from a neighbor, you can compare your own value with what you get from the frame. And so this is a reference of your neighbor. So basically, if you have the same numbers, this means that you are on the same phase. And by computing the delta, the difference between your value and the value sent from your neighbors, you can compute the phase difference. And you can also have the inverted, for example, phase. So you can have 6 basically state, which is if you are on the same phase, on the phase before, on the phase after, so phase 2, phase 3, if you're on phase 1, or if you are on an inverted phase, which is very important for security reason in France. If you have an inversion in the phase, it can be a problem because when you have some switch that are switching off the active conductors, if you have an inversion, it can be dangerous. So G3 provide by nature this information. You may not have this kind of information with some wireless protocol, for example, because they don't use the wires to communicate, for example. So if you're going to the next slide, this is some result from real networks we have in France. So we compute the phase, the phase repartition, and saw that on these networks it was mostly balanced. We have roughly 900 meters on phase 2, phase 1, phase 3, so it's quite balanced. But we detected some inverted connections, so some problems that happened during the rollout. It has been wrongly connected. So this is something that can be dangerous, and we have to send a technician to correct it on the field. And this is just using PLC information that we saw this. On the next slide, this is the last service I will present. It's about the grid cartography consolidation. So when you use PLC, you use wires. So basically, when you look at all the connection on the PLC connection, which is on the left side, PLC G3 PLC is using a routing protocol that creates what you see on the right side, which is the routes. So all the path needed to join all the meters. And so it's quite useful to look at it. If you are going to the next slide, we can, for example, look at all the connection from the grid perspective. So we have database and we know the connection on the electrical side, but using PLC, you have all the connection on the communication side. And what is interesting is that you can mix them. So for example, on the right side, we use color which match with our grid database. So this is what we know so far. And all the community that you have is created using the PLC information. And this should basically match. So for example, we have the yellow community. It is quite strange because we see 2 yellow communities. So the grid database say that they are all connected to the same point, but the PLC connection says that they are not communicating together. So it's quite strange. So if you are moving to the next slide, you will have the explanation of what do we actually see. So actually it was because of this building. So it is a real network that we have in France. Actually, in this high-rise building, you have two, I will say, two feeders, like they are not connected on the same point. So we have the floors from number 9, from 1 to 8 that are connected through wires, and the upper part of the building, which is between floor number 9 to 16, are connected to another wires. And from our grid database, we thought that we are connected to a single electrical point because we don't know beyond the connection of the building. So actually, PLC can know more than what we actually have in our grid database, because it can see that some floors, some meter from some floors are communicating together. So it can automatically know who is connected to what at the electrical level, which is very important when you are operating a grid, because sometimes you have some work and you don't update your cartography. So it's very important to automatically have this information and be sure that everything is correct in your grid database. And this is actually what can be done using PLC information. So on the next slide, I'm showing that all these services are working together. So for example, when you detect an outage, this is the first services. Actually, when you match it with a grid cartography consolidation, you can actually know where your problem is. You know that you have an outage, you know where it is due to the cartography, and using the phase detection at the end, you know even more that on what phase you can have the problem. So it's you know it's like know more and more about your problems. You know you have a you have a default, you know where it is and you know what phase it is. So it's very precise, and we can send a technician on the field at the right place very fast, and it's very much more efficient than sending people on the field and looking and seeking for the problem. It could take a lot lots of time on the field, and now we can do it remotely from the office. My next slide is also to say that we actually build a lot more of smart grid application. I just presented 3 of them, but this is a list of all the services that we build on the G3 PLC program. So we can, for example, see over voltage alarms. We can remotely ping some meters if you want to diagnostic something on the grid. You can do a lot of things. There's another slide which is presenting even more services that we developed. So I just focused on these 3 services, but you have to know that we actually have more. And so if you want to know more, just get in touch with me or any Alliance members. And to go to my last slide, what will be the best for you when the COVID will be over, is to visit NED's facilities. You are very welcome when it be possible to visit our lab. We have big labs. This is actually my lab when I'm working every day. So we have a lot of meters, lot of electrical appliance, and we can show you demos and everything that we build using just a simple meter. It's much more than a meter. It's actually a sensor that provides data that has a lot of value for a DSO. Thank you for your attention.
Thank you very much, Cedric. I believe everybody had a very good overview of the smart metering program, one of the world's largest smart metering program happening in Enedis in France. So now I will take another few minutes to invite Dr. M.S. Kelly to give a quick overview of a 3 minutes overview of the Tripura project, because many of the participants of today's webinar do not know about a large 40,000 meter project has been done in India. So Dr. M.S. Kelly, please come. Over to you, sir. He is the managing director of the Tripura Electricity Distribution Company, owned by the government of Tripura, which is a state in the northeastern part of India. Dr. Kelly, can you hear us? Are you there?
Yeah, I'm there. Just a minute. Hello, namaste. Reggie, am I audible?
Yes, you are audible. We can see you. I will stop my video so that people can see you. You can switch the video if you like.
Okay, warm greeting to all the panel members and the participants in this webinar. Actually, Tripura is a very small state, but they have implemented very big project, big pilot project for the smart metering based on the PLCC communication. We have installed 42,000 meters through PLCC communication, and they are working well. We are getting near about more than 85% of the communication. Features of the our project are major AMI for the remote meter reading, remote connection disconnection, then theft detection, prepaid and postpaid facility was there, real-time monitoring and peak load management, which was the main features of our project. We have used the PLCC communication, and it was through cluster architecture. Yeah. Just move the slides. Rajendra, next. It is the cluster architecture of our project. Next. I will take 3 minutes only.
Sorry, I think there's a lot of background noise. May I request Mr. Pillai to mute himself? Maybe the on his side.
Yeah, echoes are there, I think. So actually,
yeah, there's still a lot of background noise.
Okay, just we will go to the actual issues. These are the functionalities which knows by all the participants. We will go ahead. Next. Yeah, these are some installations, and these are some pictures which we have captured. Next. Yeah, it is also just next. These are general. I will just highlight the issues. These are the comparison between the 1 minute. Just stay on this slide. Previous slide. It is the comparative analysis of all the technologies which are being used in the India. One is PLC technology, which is in the Tripura. RF technology, where I have worked there, Indore project. We have installed 75,000 meters there with Salient. And GPRS, these are some technologies. I have just compared what are the advantages and disadvantages of the various technologies. PLC is there is no issues of the line of sight issue. It is just plug and play arrangement, and no repeaters are required. It is useful for the high-rise building because there is no issue of the line of sight. These are some advantages of the PLC. Then in RF, there is a faster installation as compared with the PLC communication. Consumer indexing is there will not be issue in the consumer indexing, and change in network does not impact the communication. And GPRS is the isolated operation, and which is used for the rural area, or we can use the hybrid technology along with the RF plus GPRS. Next. These are the benefits that additional wiring for the communication not required in the PLCC. Then I already told you about the line of sight issues. Then it is having a low susceptibility to the elements such as any weather conditions, fog is there or rainy season, there will not be any issue. Operational cost is low as compared to the other technologies. Repeaters are not required, and there is not effect of any external factors. Consumer indexing, there are some issues. I will give details in the technical and general. Next. 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 These are actually techno-commercial performance, which was we got the results of the smart metering. Previously, there was okay. The AT&C losses, which were reduced after the installation of the smart meters, 11.5% to 4.38%, and even our collection efficiency has also increased, and there are no issues of the billing. Next. I think it is the interesting part. What issues we are facing, or what are the general issues while implementing the PLCC technology in the Tripura. Actually, it was a new technology that awareness about the technology was one of the general issue. Then manpower training. Everybody should own the project, but being a new technology, nobody was knowing about the technology, and training were required previously. Now they are trained. Then adaptability by the stakeholders, means we were the major stakeholder, and adaptability which are adopted by us. Consumer indexing is the issue, because if we replace the transformer, any transformer, then if there are some changes in the consumer, then indexing is one of the issue, because the mapping is required and delta updation is also required after replacement of the distribution transfer as well as the CTs. Then one of the typical issue which is faced for the power line communication is the because it is communication is being done through the line, though old lines and joints in the conductor and jump ring, these are some issues which are faced by the any utilities, because in India there are so many utilities which are having the old and deteriorated infrastructure. That's why it is the typical issue which is observed by every utility. Then communication issues due to updation in the firmware, it was issue we have faced. And after disconnection, we have observed some issues in the remotely reconnection. Another, next. OEM dependency was the issue, because we have partnered with Powercom, and now support from that has been withdrawn, and we are facing some issues. Then there are technical issues in updation of the software, because wait time on the DCU for linking with the meter to DCU and identification of the efficient communication route was slightly sluggish. Variation in the impedance of power line, which was affecting due to some factors, that time, loading, carrier frequency, and also location, means rural as well as urban or the industrial. It is a difference in the impedances. Then signal attenuations were observed. Household appliances, they also impacts on the impedances, and signal level is limited to the very, very lower level. Next. Next. That's why actually we have in the previous IEEE webinar, actually we have suggested some detailed study should be done by the expert group through IEEE or any, if somebody is interested in doing study on the PLCC communication projects which is being implemented in Tripura, it will be welcome step. Then researchers and power industry or the investors may think for the future development of such type of projects in India. And there are some issues in the availability of the spares, product support, services from the OEM that we are facing presently. And if we compare with all the technologies, per node cost in the India is very crucial. Recently, actually, if we compare with the RF technologies, it is as compared with that, it is less in the PLCC mode.
Sir, we have to close ASAP. What is your way forward? Please explain and close this, sir.
Yeah, detailed study of the project is required for rollout in the remaining part of the India. I think it is the most crucial way forward for such type of projects.
Thank you very much. We will be very happy to undertake another study.
Yeah.
Earlier, National Smart Grid Mission had appointed There is some background sound coming. I don't know what is it.
Yeah, there was a technical committee. They have studied this project also.
Yes. There is a report which is generally positive. We will again request MOP to appoint a committee to study this. Now,
Okay.
I will now request my friend Avenir from Israel to speak for a few minutes. Sir, 3 minutes to you, Mr. Avenir.
Yeah, okay. Do you have the slides coming? All right. Okay, my name is Avner Metmor. I'm the founder and the CEO of Itran Technologies. We have established Itran in 1996, so that's already 24 years, with one aim, actually, and we stayed with the same aim. Hold on.
I don't want you to talk here. Get out.
Do you hear me well? Maybe we should all mute.
Yeah,
we can hear you.
Okay,
Please,
good.
those who are on-
All right. So the aim of the company from the beginning was to come up with a power line communication solution that will overcome all the problem that Mr. Muhari Keller was just mentioning, that power line communication has, and that is a lot of noise, attenuation, change of impedance modulation, different hours in the day where people are coming home, starting to operate their appliances, and so and so and so. You also could see before that the different forums already are trying to overcome the problem with coming up with a combined solution with RF, because power line communication sometimes has an issue. Obviously, nothing is 100% perfect, but power line communication, and especially in India, unlike in France where the grid is very clear, so everything is okay, more or less. In India, it's terrible, and I'm sure that all the audience that is sitting listening to this session is saying, well, we had some bad experience in the past with power line communication. So this is what Itran did, okay? It came up with a spread spectrum DCSK technology and with a distributed MAC to really overcome the problem that terrible grids are bringing. And it is a fact today that Itran is very successful in areas where the grid is bad. In Russia, in Ukraine, in Brazil, in areas like in the east of Europe, in some of the areas in Africa. And of course, there are also other issues that might encounter from the fact, for example, that you have underground need to have underground communication without any repeating and so forth. So you have to go long distance and so forth. This is where Itran comes in, okay? If you test our technology, we've been there for 20 years. I want to be modest a little bit, but we always come very good, okay? Very good in the result, in the reliability and so forth. Of course, you have to keep the cost of the solution low, so adding more and more features or more technologies to the one that you have already on the PLC makes the solution very high in cost. We don't have the indexing issue, okay? We show that in India. We have a site that works very well in New Delhi for many years already that we can show. And we also established, in order to be more active in India, we established a partnership with a company called Hybrid Sync, which was founded to work with Itran on bringing the solution to India. The group in Hybrid Sync is very experienced in our power line communication for more than 10 years already, and they also bring the upper level communication solution to the solution. So we have a local group that is capable of supporting anybody that needs the support. Can you go to the next slide? So we show here the Puducherry pilot, which was conducted between, I think, 2012 to 2015. It's in the south east coast of India, Indian Union Territory of Puducherry. There were 2 sites there, as you can see, and you can see that green dots here and here to show that most of the nodes that were tested at a specific hour showed the full communication, which was very successful. By the way, the PLC, I think, showed here that it was the best solution in general. A few other technologies were tested, and PLC was very successful in this area. There were 2 sites that were tested, and this is just a quick slide to show you. By the way, you see here more than 1 kilometer coverage and so and so. Next slide.
Avenir, I am afraid we are seriously out of time.
Yeah,
So
okay, this is the last one, just to show the data concentrator unit and the fact that we have up to 16 hops, automatic registration, and self-ending. I appreciate very much your attention, and also to you, Reggie, for the time you've given us, and we hope to be here 30 minutes next time. Okay, thank you very much.
Thank you very much.
Thank you.
Look forward to.
All right, thank you.
Thank you. We are seriously out of time, and many of the questions which were there in the chat box I answered. Also, Dr. Manoj Kumar answered. There are 1 or 2 questions which are not been answered, which we will mail it to the concerned people. Since we are running out of time, and I already said that 7 o'clock I need to join another panel on the energy storage part. I will now request my colleague Reena to conclude the session and also say vote of thanks. Reena is Executive Director with the India Smart Grid Forum. She brings over 20 years of experience, rich experience in the energy sector. She's with ISGF for 7 years now, and had done most of our ISGF work is handled by her. And over to you, Reena.
Thank you so much, sir, for the kind introduction. And so this brings us to the end of today's webinar, and I would like to thank you all for joining us today and for this webinar organized by IEEE Standards Association in partnership with India Smart Grid Forum. So this was the 2nd webinar of the series. First webinar was held in July on successful PLC technology use cases in India and Europe. And we plan to continue this with bringing more experiences and use cases from around the world with our future webinars. I take this opportunity to firstly thank Mr. Ravindra Desai for spearheading this initiative and having ISGF as a partner for this important initiative. A big thank you to our speakers, Dr. M.S. Kele, Managing Director, Tripura State Electricity Corporation, Dr. Leon Verdier, General Secretary, G3 PLC Alliance, Dr. A. Pavintan, Chair IEEE ICPLC Test Beds in India, Dr. Manoj Kumar, Director, ST Microelectronics, Mr. Cedric Chauvenet from PLC Enedis, France, and lastly, Mr. Avnar Matmore from Yatran Technologies. And to our moderator for today's webinar, Mr. Reggie Kumar Pillai, President ISGF and Chairperson GSGF, for your insightful presentations and very thought-provoking points put forward regarding the PLC technology. So thank you for enlightening us, us and the participants with your expertise and hands-on experience on PLC technology, its use cases in India and Europe, and all the benefits of PLC for the grid services that it offers, and what could be the next generation or future deployments of PLC particularly in India. And lastly, thank you to all our participants for your participation and for your active questions shared for our panelists. We'll try to come back to you with the answer. Most of them have been answered by Mr. Pillai and Mr. Manoj, as Mr. Pillai informed, and we will try to collate them and share with you with the recording of the today's session. So we are very glad that we had more than 170 people participating in today's session, and we look forward to continued participation from your side for our future programs. And owing to paucity of time, we couldn't take forward the question answer session, but hope we will we'll be able to address some of the questions in our future programs. So thank you once again to our esteemed speakers and moderators. We really appreciate your taking time to be part of this webinar. So with those words, Irina Suri would like to thank you all for being part of this webinar and hope to have your participation in our future events. Please stay safe and take good care. A very good evening and good afternoon. With that, we close today's session. Thank you once again.
Bye.
Big thank you to Reji, Reena, and IGF team. Thank you.
Thank you so much.
Thank you.
And Mr. Ravindran. Thank you.
Yeah.
Thank you everyone. Yeah.
Thank you
So much. Please take care.
Thank you. Bye.